What I'm going to do is pass it on to VeloDB's team with Rainer and Kobe, and they can introduce a little bit about VeloDB and Apache Doris and why we're so excited to partner with VeloDB and their tech stack with Apache Doris. It's a really exciting time for folks in the data space, especially with all these powerful data tools and software and warehouses like VeloDB. And Rainer's going to walk us through what's so exciting about Apache Doris. What can folks like, the people in the audience here take away with Apache Doris, but also with VeloDB? What makes VeloDB special as an enterprise provider for Apache Doris? And Rainer, I think depending on whatever slides you have, we have people in the audience who are going to be across industry. So if, some of the use cases, you could present a variety of use cases across industries, whether it's, financial services, healthcare, et cetera, et cetera. That'll be great as well.
Okay.
So I'll hand it over to you, Rainer. Thanks a lot.
Okay. I'll share my screen. Okay. Get started. Is that okay? Can anyone see my screen?
Yeah, we can see it.
Okay. Okay, now let's get started. Okay, hello everyone. Thanks to the WeCloudData for organizing today's webinar, and it's a pleasure to be here to share with you some exciting insights around our topic, the Apache Doris, the fastest analytic search database for the AI era. Okay, let me start with the quick introduction. My name is Rainer Chen, and the co-founder of the VeloDB, and also the PMC chair of Apache Doris. I've been working on the Apache Doris project for nearly a decade, since its early days, deeply involved in both its technological architecture and community growth. So the VeloDB is a company I co-founded, was established by the co-creator of Apache Doris, and we are focused on providing enterprise-grade service and commercial support, helping organizations to get most out of Doris in the mission-critical scenario. All right, let's dive into today's topic. I've broken today's session into two parts. The first, I know that some of you may not very familiar with the Apache Doris yet, so I will start it with a brief introduction. We'll look at what Doris is and how it evolved its core architecture and how the open source community around it has grown. And then in the second part, we will shift gear to talk about AI, specifically how the rise of AI application is reshaping the expectations for the modern data infrastructure, especially database. I will walk you through what kind of challenge this new AI scenario brings, and more important, how Apache Doris is purpose-built to meet those challenges, make it one of the most ideal database system for the AI era. Okay, let's get into the core of today's topic, what exactly Apache Doris and why so many companies turning into it in this new AI-driven world. So let's start it by introducing a project. It's the Apache Doris. To sum it up in one line, Doris is an open source real-time analytical database. You may think of the name Doris as some kind of old school, but trust me, it got charm and character that never go out of style. As you can see from this diagram, Doris is designed for OLAP, or the online analysis processing, not for the OLTP or the online transactional processing. It sits right at the core of the modern big data architecture, act as a unified query and analytic layer across a wide variety of data sources. So at the bottom, we have all the data sources that Doris can connect to. That include the traditional database like the MySQL, the PostgreSQL and Oracle, as well as the streaming system like Kafka and Pasa. But one of the most important categories, especially for the modern data platform, it's the open data lake format like the Iceberg, Hoodie, and the Delta Lake. And Doris also supports the Firebase source like Parquet or on the object storage or even the HTTP-based event stream. So now Doris gives you two main ways to work with this data source. The first is a classic approach, the ETL or the ELT pipeline. You can use the upstream system like Spark or Flink to process your data and load it into Doris for the fast querying. Or you can let Doris ingest the data directly. For example, pulling from the Kafka topic or reading the file from the S3 and transform that into Doris internal storage format. In this case, the data is stored in Doris, and you can query it using the standard SQL, just like the database you're already familiar with. And the second approach is the federated analytic. Doris comes with a rich set of connectors that allow it to query external system directly without importing the data. A common example here is to query the iceberg table. The data stayed in the data lake, and Doris acts as a powerful distributed query engine that scans, analyzes, and returns results in real time. So in summary, Doris is not just a full-featured database with its own storage and computation. It also worked as a high performance query engine to accelerate access to the external data source. Okay, now let's take a look at the system architecture of Apache Doris. So one of the things we really focused on is keeping things simple. So from an operational perspective, Doris has only two types of components, the front end and the back end. And you can forget all about other like HDFS, the Zookeeper, sort of that. All that is not needed. So the front end is a control plane. It handles tasks like the client request handling, the metadata management, the distributed coordination, and the query planning. It is written in Java, and it implements a MySQL protocol, which means you can connect to Doris using any standard MySQL client or driver. And that makes it super easy to adopt. No new tooling or protocol learning curve required. So on the other hand, the backend is the execution engine. It handles all the heavy lifting of the query processing and the computations. So it is written in C++ to deliver a high performance, especially under the complex, the high concurrency workload. And now Doris supports both traditional massive parallel processing architecture with the classic, we know the share nothing model, and also a modern cloud-native architecture with the compute storage decoupled architecture. So on the right side of this slide, we only show you the decoupled architecture looks like. At the bottom, Doris uses the object storage like S3 or the HDFS as a shared data layer. So on top, you can run multiple stateless compute groups, each tailored for a different workload, whether that's the BI dashboard, the real-time ingestion, or the AI-powered query. And all of them share the same data, so we call the single source of truth, which ensure the consistency and the efficiency at scale. So in short, Doris offers a modern, flexible architecture that supports a wide range of deployment strategy, operational models, and user needs, whether you are running on-terms, hybrid, or fully in the cloud. So now let's take a more user-centered look at what Doris really is and why people love using it. So this quote here actually comes from one of the users on LinkedIn, and honestly, I couldn't have said it better myself. So it's short, sharp, and really capture what makes Doris stand out. So first, when do you need something like Doris? Well, if your dashboard are still saying last update several minutes ago, so you probably need Doris. So if your query are taking copy break time instead of a millisecond time, so you definitely need Doris. And if you are serving thousands of users at once and don't want your system to melt, so again, so you need Doris. So and here is the best part: you get all that without breaking the bank. To give some perspective, let's line Doris up against some familiar names. So we may all know the Snowflake, and compared to Snowflake, Doris give you the real-time visibilities, not just wait a minute, refresh, and try again. And compared to the BigQuery, which is provided by Google, and Doris is blazing fast, especially when things get complex and concurrent. And compared to a ClickHouse, which is a company from Russia, and the Doris handled not just the speed, but also the on-the-fly join. So you can join table together and the lakehouse workload and more, and with a lot less headache. So again, just to clarify, Doris isn't built for the OLTP, so you are not going to use it for the banking transaction or something. But it does support transactional ingestion, so you can count on the data consistency and atomicities when loading data. A big deal for some serious use case. So where does Doris shine? So in e-commercial dashboard, where data is changing every second, or in the fraud detections or real-time alerts, where every second counts. And in some scenario where the business says, I want the result now, not a minute later. So to sum up, Doris is a high-performance, real-time analytic database that is fast, flexible, and surprisingly fun to work with. Perfect for the data demands of today, and especially for the AI-driven tomorrow, which I would like to explain more later. Okay, this project actually has a pretty long journey. It dates all the way back to the 2013, and we open sourced it in the 2017 on the GitHub. And at the next year, we donated to the Apache Software Foundation incubator. And after going through the incubation process and years of active community development, Doris officially became the top-level project in 2022. And since then, the community has grown rapidly, and we're now approaching around about 700 contributors around from all around the world. And the project has received over 30,000 GitHub stars and counting. So in fact, the Doris website is one of the most visited across all the Apache projects, which show just how much interest and momentum there is. So as an Apache project, we are fully committed to building a diverse, open, and vibrant big data community. It's one where the developers, the data engineering, and the companies can all collaborate, grow, and innovate together. So this is the logo wall of Apache Doris. We have got over 5,000 enterprises worldwide relying on the Doris in the productions. So whether it is the open source Apache Doris community user or the commercial customers using the Doris-based solutions like ValueDB, so these users span a wide range of industrial, from the finance and retail to the entertainment and the telecommunications. This really shows how versatile Doris is. It's not just a one-trick pony, but a Swiss Army knife for the real-world data challenge across the sectors. So to warm up, a quick but comprehensive intro to Doris. But trust me, Doris has a lot more cool features, the user cases and real-world scenarios up its sleeve. And we will be diving into these scenarios in the upcoming live sessions if we have opportunities. So now let's get to the heart of today's talk. So what kind of database does an AI era really demands, and how Doris rise to become the chosen one? So first of all, we believe that in the AI area, the AI-driven data processing sets three key requirements of the database. So number one is the high-quality data foundation. We all know that the buzzword around the large language model is large. And that large doesn't just mean the hundreds or billions of the parameters. It also means the rich, diverse data. There's even talk, I don't know it's true or not, that there aren't enough new public data sets left to further train the GPT models. So whether that is a fact or a rumor, it is highlight that an important truth. The successful AI application absolutely need a massive amount of rich, high-quality data to stand out. So data is foundation for the AI to understand the world. So now if we zoom into an enterprise, there's tons of highly relevant data locked inside the relational database like PostgreSQL or the Oracle, or data stored in the open data lake like Iceberg or Delta Lake, or even standalone Parquet or or scattered all over. So the challenge is how to unify and integrate all the data efficiently. So the traditional approach often means to build lots of ETL pipeline to pull everything into a center data warehouse for analysis. But this can get messy and slow, both in management complexity and the real-time freshness. So a main need is how to efficient manage multiple data sources in a unified way to maximum data utilizations. So the number 2 requirement is the unified and efficient hybrid search. So once you connect it to all those diverse data sources, you hit the next challenge, the data variety. The traditional database mostly handle the structured data like the tidy relational table with clean numbers and strings, but there's also tons of semi-structured data like JSON, which is common in logs, metrics, and tracing. And with AI, and also with AI, the need of analyze unstructured data grow rapidly. But we know that storing the raw image or the audio or the video files directly in the database is inefficient. So when we talk about the unstructured data in the database, we are talking about the vector store and the vector search. So the text image will be embedded and stored, and then the database use the vector index or the similarity functions to quickly find the close-set match. And this is crucial for the things like the enterprise knowledge base or the RAG, or we call the retrieval augmented generation. So in short, the ability to search across the structured, semi-structured, and unstructured data efficiently and in one place unlock the true value of the diverse data. So the number 3 requirement is the AI-ready data observability. So the high-quality AI needs to solid training, and the training generates tons of logs, metrics, and events. By analyzing this event-driven real-time data stream, we can monitor the model training and the runtime status and response quickly to change. So plus, with AI agent become more common, their interactions, whether it's agent to agent or the agent to the large language model, generates lots of logs and trace. This data help us better manage the agent in production. So meanwhile, the database itself is often an access point for the agent. For example, to exposing the data to a large model through the MCP server. And this means datasets must handle thousands of concurrent agent requests, pushing the bar high on the concurrency and the real-time performance. So to sum up, the unified data management and the efficient hybrid search and the real-time observabilities from the 3 core capabilities a database must provide to support the AI application in today's world. So next, let's zoom in on these 3 pillars and see how Apache Doris step up as the ideal data infrastructure for the AI era. So first up, let's talk about how to provide the high-quality data foundation. This breaks down into 2 parts. 1, so how to quickly integrate data, and 2 is how to deliver the high performance data analytics. So let's start with the data integration. So we've emphasized before that Doris is a full-fledged database system or a complete DBMS with its own compute and storage layer. So it can run independently and serve data efficiently. But in the AI era, like I said before, the real challenge is the breaking down data silo that blocks seamlessly interactions between the AI application and the rich data inside enterprise. So beyond analyzing data stored inside itself, Doris comes packed with a wide variety of data connectors. And that means Doris can directly access the external data source without relying on the complex ETL pipeline or extra data replications. So plus, Doris supports federated query across the multiple data source. For example, you can write a single SQL query that join the data from a iceberg table with your data stored in the PostgreSQL, or read the data from the Oracle and write it directly to the Hive table. So these connectors help bring the diverse enterprise data together making it easier to analyze a relationship across the dataset. And on top of that, Doris deeply integrate with mainstream open lake formats like Iceberg and Hoodie, like I said before, and building a solid lakehouse architecture. So if you guys follow the Iceberg community, you know that it's constantly evolving and adding support for some semi-structured data type. So it already good at the structured data, and now it involves the semi-structured data, like the variant for JSON and geographic data and the lens format from LensDB for the AI training. So the lakehouse architecture itself is moving forward unified data storage. So you can think of it like this. So at the bottom, there is a shared storage system like the S3, and on top of that, the open file format, and the pair with the unified the metadata service like the Unity catalog, the Hive meta store, and or the AWS Glue, and finally a high performance query engine tying it all together. So this open unified stack lays a strong foundation for the high quality data integrations. So within this architecture, so Doris acts as a unified the open data lakehouse query engine to providing a single pane for analyzing all your data. So all right, let's talk about performance. So because for a query engine, like I said before, speed is the king. So we all started by looking at some straightforward benchmark results from for Doris. Of course, the benchmark onto the whole story, the kind of like so if you win a math contest, doesn't automatically makes you a math genius. So but this test do give us a quick, easy way to get a feel for the Doris performance. So first up, there is the ClickBench suite released by the ClickHouse team. And this test aggregates queries on a wide table with about 100 columns, and focusing on how well the engine handles the big data aggregations. And so you can see the Doris ranks near the top. And the next is the JSON bench, also from the ClickHouse, which tests the JSON query performance. Doris again is shine and leading the pack. So then we have at the bottom, we have the classic TBCH and the TBCDS benchmark. So this simulates the complex multiple table join, test not only the raw system power, but also how smart the query optimizer is with the complex SQL. So for comparison, we picked the Greenplum, which is a distributed version of PostgreSQL, and the Trino. And then interesting, the Doris with Trino comparison is especially interesting because both query the same Iceberg table stored on S3. So across both benchmark, Doris is multiple times faster. So now, just to be clear again, benchmark don't tell the full story. So the real-time performance depends on a lot on your data types, the distribution, and the query patterns. So, but we encourage you to try this test yourself and see how Doris performs in your environment. Okay, and then we talk about the when we talk about the query engine, a lot of names probably comes to mind, like Spark, the Trino, the Presto, and so on. So we just show you some performance benchmark where Doris holds its own and even leads. And but here's the thing: the performance alone isn't enough to make Doris stand out in the sea of those great systems, because everyone improving all the time, right? So the performance is just endless war, in my perspective. So I want to highlight another core design philosophy of the Doris, the seamless integration of data lake and the database. So we've said before that Doris is a complete database system with its own storage. And that is what really sets apart from the pure query engine like Trino. So these other engines don't own their storage. They just query the external data source. That means that their power is limited by the external storage format and how well those storages are tuned. So for example, when you query the Iceberg table with Trino, And if the iceberg table isn't carefully optimized, like the data sorting, the compaction, or the indexing, the Trino can't work its magic efficiently. So Doris, on the other hand, leverages internal storage format to boost its query engine capabilities. So it merged internal and external data formats to offer a richer and more powerful query service. So this diagram on the left show how smoothly Doris integrates these two words. First, there is the fundamental data caching. So when Doris queries the Parquet or ORC files in Iceberg or Hive, it usually needs to fetch data over the network from the HDFS or S3. So that access pattern tends to have also have the high throughput, but also has a very high latency and limited concurrency. So it's not great for the real-time analytics. So Doris solved this by offering a built-in Fireblock level caching that store the part of data locally on the local fast disk. This means the hot data query can run super fast. So next is the materialized view. The materialized view acts as a critical bridge between the open format and the internal storage. The user can define the materialized view, and it will pre-compute and store the external data in Doris internal format with a flexible access method. So first, a user can query this materialized view directly, since they use the Doris to optimize the internal format and are pre-computed. So they are perfect for high concurrency, low latency workloads where data changes on too frequently. And even cooler, Doris supports the transparent query rewrite based on the materialized view. So when user run query on the original table, Doris, the query optimizer, will automatically rewrite them to hit the most relevant materialized view behind the scenes. And for user, it's seamless acceleration without changing their queries. So having a robust internal format let Doris do things that other query engines can't. And since the internal format is tightly coupled with the execution engine, so it delivers the better performance and the richer features than the external format. So for example, Doris supports the advanced index, the variant data type for JSON or for semi-structured data and more, which I will cover in the detail later. So in summary, Doris is the query engine that fully leverages the internal format to provide a unified lakehouse analytics. That is the key feature that really sets Doris apart. So this slide lists some key technology features behind Doris extreme query performance. But due to the list time constraint, I won't dive into each of these today. But you may already recognize some familiar points that we talked before, like the materialized view, the cost-based optimizer. We already saw it validated in the TPCDS benchmark, and the vectorized query engine, the MPB architecture, various index method, and more. So together, this technical building blocks power Doris' impressive analytical capabilities. Okay, now let's circle back to the AI area to see how the real-time data analytics has evolved from the big data area. The most classic real-time analytics scenario is what we call the customer-facing analytics. So this covers a wide range of user case, the order tracking, the advertisement performance, the inventory monitoring, and these are interactive user-facing analysis that demands accurate and freshness to help people to make timely, efficient decision. So now in the AI era, especially with this year being called the year of agent, many tasks that used to require human decision making or the manual operation are now handled by the intelligent agents. So each agent acts as a domain expert, and the database especially become their knowledge base. So often a single command may trigger many agents to simultaneously acquiring the database. This means that the concurrency level and the query volume can be several orders of magnitude higher than the customer-facing scenarios. We call this new challenge the agent-facing analytics. So it demands a much higher concurrency, the low latency, and the blazing fast responsiveness. So Doris is designed to support both the customer-facing and the agent-facing scenarios seamlessly. It offers near real-time data ingesting and update, and millisecond-level query latency, and the ability to handle tens of thousands of queries per second, capability critical for agent-facing workloads. And plus, Doris provides an official MCP servers, make it easier for the large models to access the data they need. So that's a quick overview of how Doris enable faster data integration and delivers high performance analytics. So the next is the second big requirement, the unified hybrid search. So as I mentioned before, the data types typically fall into three buckets: the structured data, like the classic two-dimension relational tabular data, and the semi-structured data like JSON, and finally the unstructured data, which is usually stored as the vector embeddings. So Doris support all three types of data stored and analyzed in one system, greatly simplifying the AI applications need to work across diverse data instead of struggling on multiple tools or one system, so that one system can handle most of the heavy lifting. So for each data type, Doris offer a targeted data structure and optimizations. So first, for the structured data, we provide the sparse index like the skip data index, the Bloom filter, or the min-max index combined with the corner storage, partitioning, and the bucketing. This feature power the efficient analytical queries. Also, the TPCDS benchmark we discussed earlier already highlights the Doris strength here. So handling the semi-structured data is one of the Doris standout features. You might have heard of the data type called the variant. This is the flexible data type designed especially for the JSON. The Doris will automatically parse the incoming JSON and store the extracted field in a columnar fashion. So let us keep the compression and the faster reads of columnar storage while preserving the schema flexibility of JSON. It is very interesting that the Arcade community, if you are interested, the Arcade community only just introduced support for the variant type this year, and it is still under discussion. And Doris, however, has supported the variant internally for 2 years already. So including the automatic JSON parsing and the column evolution, and with the variant data type, Doris strike a sweet spot between the performance and the flexibilities. So on top of that, Doris also provide a full text search based on the inverted index, which is a huge help for the log analysis and like the similar scenario where you need to search text context inside the semi-structured data. And finally, there is the vector storage and search. Doris support the complex nested type like the array, map, and the struct. And we use array to store the vector data and provide the vector index constructions. So the diagram here show how the text, image, and audio video data get converted into embeddings and stored as the array. And with the vector search built in, Doris extends its ability into the AI application domain, like the RAG, and opening the new frontier for the unified data search. So let's take a close look at the concrete example of RAG's hybrid search capabilities. So on the right, you can see the architecture diagram of a typical RAG setup. As I mentioned before, data gets converted into embeddings and then written into a Doris vector storage, which serve as a retrieval source for RAG. And when user asks questions, the large language model query stories to retrieve the most relevant context, which help generate a more accurate and informed response. And what this architecture also shows is the power of hybrid search. So Doris isn't just a pure vector storage, as I said before. It also provides a robust support for the structured and semi-structured data analysis. So users don't need to deploy other systems for different data types, greatly simplify the overall data platform. So for example, you can use the large model and the RAG to generate a complex SQL query in natural language, and then run that SQL directly in Doris to efficiently query the structured data, all within a single system. So typically, a typical user case include the QA system that pull precise information from the database, or the enterprise knowledge base that leverage Doris in the real-time data updates to keep the information fresh and useful. So these capabilities can significantly boost the operational efficiency in many organizations. Also, finally, let's talk about the AI-ready data observabilities. So this year is being called the years of agent, and we are seeing a clear trend that observability is expanding from its root, like in the cloud native and the microservice, into the realms of the large model and the intelligent agents. So back in the 2013, the companies like Twitter started to leveraging the observability to boost the efficiency of their complex internal system. And by the 2020, the observabilities was booming in the DevOps world, with organizations reconstructing their IT infrastructure to cut costs and improve performance. And fast forward to this year, the 2025, the rise of intelligent agent is pushing the observabilities to the forefront in the AI era. So how Doris fit into the observability landscape? First, let's talk about the observability data. It typically fall into the three main types. So one is logs. These are the high volume and often rapid changing in structure. Thinking JSON log with involving schema where columns might be added or moved at any time. So Doris stores data ingestion capabilities, and so Doris has a strong data ingestion capabilities and the native JSON support, so make it an excellent fit here. Plus, we leverage the client and server side batching processing and the time series compaction policy for the log data. So Doris can boost help Doris to boost the throughput even further. So second data type is trace. The trace data monitors the health and the bottleneck of like a distributed system. So it need very fresh data observabilities. So the data usually is structured and the required updates based on the trace ID or span ID. So Doris has a primary key model to handle this real-time update very well. So last is metrics. Metrics are monitoring. This is monitoring data that also need a real-time process and is often aggregated. So Doris has a built-in pre-aggregated model. That let it compute and storage aggregated in the background, so the query can quickly return the pre-aggregated result directly. So to sum up, using Doris to power the observability platform can yield up to a tenfold improvement in efficiency. So Doris offers a complete end-to-end observability toolset for log data. We integrate with popular log shippers like Logstash and Firebase. And for trace and metrics, we tie into the OpenTelemetry ecosystems. So on the visualization front, we support the Grafana and also provide tools similar to the Kibana discovery for the log visualizations. And this make it easy for users to build a comprehensive data observability platforms. And now coming back to the AI scenario, this diagram on the right illustrates why data observability is so critical in the AI. So think about all the logs generated by the AI agent in the operation, and the monitoring metrics and the trace data created by communications between the agents themselves or between the agent and the large language model. all this needs efficient monitor to better guide the training and the fine tuning. So with Doris, we not only get unified data storage and analysis capabilities, but also massive gain in write and query performance. So compared to the Elasticsearch in the log scenarios, the Doris offer up to 4 times faster write speed and 2 times faster the query speed. And even more importantly, the storage cost can be reduced by as much as 80%. So this kind of efficiency boosts a game changer for the enterprise aiming to cut costs and improve the productivity. So alright, okay, let's that wraps up the main content I want to share about the Apache Doris Day. To summary, here are the key takeaways. So first is the lakehouse architecture provide the unified data management and analysis capabilities, delivering the vast amount of high value data to power AI. And the second is Doris high performance and hybrid research capabilities give enterprise an exceptional analytic experience, which reducing the system manager and the operational cost. At the same time, it helps the intelligent agent perceives change in the world in real time. So the last is comprehensive observability solutions ensure the AI applications to enjoy more stable and high quality operations. Okay, now finally, a quick introduction to our company, the WeCloudDB. So our mission is to bring the power of Apache Doris to the world, and we currently offer the semi-managed bring your own cloud service and the fully managed the SaaS cloud product on the AWS, the GCP, and the Azure, and fully compatible with Apache Doris. And our goal is to provide the user with a more stable, secure, and efficient unified data analytic platform. So we warmly welcome you to join the Apache Doris community. And this is our official website, the mailing list, and feel free to scan the QR code to join our Slack, and where you can ask questions, change ideas, and get support or collaborate. And we look forward to build a stronger Doris ecosystem together with you. So that's all. Thank you all for your time and attention.
Great, thanks, Rainer. Thanks for a really good introduction to not only Apache Doris, but also VeloDB, but also some of the primary use cases that the VeloDB and Apache Doris is being used for across even the AI stack like you were showing, including GenAI and RAG LLM search. So we do have a few questions in the chat here. We're going to go through some of the questions in order where they were asked, but after that, feel free to open up your mics, folks, and ask Rainer questions. So Rainer, I'm just going to go through some of these questions. For example, Shivaji asked, how does Google Looker or Google Looker Studio connect to Doris? Does Doris have dedicated connectors, or does it depend on the MySQL? And if MySQL connector is used, does all the MySQL queries get executed on Doris? How does the execution and the connection with MySQL work? And what about connection to Google Looker?
Okay. First, let me explain. So the Doris expand the MySQL protocol layer, but it's not a MySQL database. So mostly the most of MySQL command can be executed in Doris, but not all of them. So you can see that for most of the BI tools or something, we suggest the user to use the MySQL client to connect to Doris. But for some special AI tool like the Google Looker, we are working to implement a special driver to connect to. So in most cases, you can select the MySQL destination to connect to Doris, but there might be some compatibility issues. If you have some issues, welcome to connect to us, and we'll help you to solve this problem.
Yeah, thanks, Rainer, for answer.
I'm sorry.
Thank you for answer. That is the
Oh,
information I was looking for.
okay. You're welcome.
Thanks, Shivaji. Did Rainer also answer regarding the Google Looker for you, or did you have any other questions regarding connection to Google Looker specifically?
Yeah,
Y-
we're working on implementing the driver for the Looker. The currently it's not Doris cannot connect to the Looker.
yes, yeah, and onboarding to Looker is a bit difficult, and that is the issue we faced in a big time on a Star Rock. We are using Star Rock internally, and somehow
Okay.
we are not able to make that connectivity work with MySQL because Looker generate with MySQL dialect, Looker generate kind of a queries that sometimes fail on the Star Rock. So I was
Okay.
just checking if there is a dedicated connector is available for Doris. That is great.
Yeah, we're working on it. It may
Okay.
be released. I think that course 3.
Okay. Thank you. Thanks, Ryan.
Mm, Okay.
Raji, you can join the VeloDB team and help them create the connector to Looker. No, I'm joking.
Thanks.
The other question from Samuel is regarding the, I think this was one of the slides about the Apache Doris architecture, Rainer. It's about the parameter analyzed to use MySQL and not Postgres. I'm assuming that the question is, why do you use MySQL and not Postgres? Samuel, if you're still here, did you want to clarify that question?
I understand that. So the question is why we choose the MySQL protocol, not the Postgres SQL protocol, right?
Yeah, I think
Yeah,
that's the question.
it's a historical issue. Like I said before, Doris, this project is come up 10 years ago, and at that time the MySQL, especially in our company, has more user than the PostgreSQL, so we just choose the MySQL protocol layer. But actually, we can see that the PostgreSQL are more popular in the data analytic area. So we are planning to see if we can implement a separate protocol layer or abstract protocol layer. So the user or the developer can implement their own protocol like the PG protocol. So it can feed both the MySQL ecosystem and the Postgres ecosystem. Yeah, but actually, for now, we only support the MySQL protocol.
Great, thanks, Rainer. So yeah, historical reasons for MySQL over Postgres.
Yes.
Matthew asked, how can someone find a job as a data? Yeah, so maybe for the career ones, we'll save it for later. We want to focus on the VeloDB and the Apache Doris specific questions. But Matthew, actually, we have Adam on here, and he's actually a program manager for WeCloudData. So maybe you should join the WeCloudData program if you want to get a job as a data scientist. But yeah, we'll come back to career related questions in a bit. How does Doris query performance compared to Trino? So Rainer, I recall you had a slide talking about Trino and some of the other databases, but it specifically, do you have like numbers comparing the performance with Trino with Apache Doris?
Yeah, actually, we had let me share my screen. One moment. Actually, we had a slide in our website to show the comparison between the Doris and Trino. And wait a moment. Hey, can I share my screen? Okay. Oh, sorry. Can you guys see my screen?
Yeah, so it's on the alternative to Trino Presto.
Yeah. This is placed from our availability website, and you can see. Okay, let's see this diagram. So this is the comparison between the Doris and the Trino, and these 3 pillars. I will explain that the first is the Trino and Presto, and the second is the Doris, and this pillar and this pillar are querying the data stored in the iceberg table. So they both query the same data. So you can see, and this is TPCDS benchmark with 1,000 gigabytes data scale, and you can see the total running time is three times faster than the Trino. And this pillar is the Apache Doris, the internal table format. Like I said before in the session, that the internal format has a more optimized, so it is more faster than we query the external external format like Parquet or the org. So this is the overview of the comparison between the Doris and the Trino. And we also have some user cases that I'm not sure, like this one and this one, and they all to change the platform from the Trino or Presto to the Doris, and to gain more performance and the cost saving. Yes.
Great. Thanks, Rainer. Farhad asks, can we please have the QR code again? Yes. Later the VeloDB team can put up the QR code on the screen again. Raj asked, is Apache Doris open source? Yes, it is. VeloDB
yes,
is the open source. Yeah.
Yes, we are the Apache project, so of course it's open source.
Yeah. Mark asks, what do you pay a serialization cost by copying the data to an internal format first? How does this affect the performance for real-time use cases?
So you mean the latency of the ingestion data? If I catch your problem, yes. Actually, the classic usage of Doris is to import data into Doris internal format and then query the data. So you can get a better performance. But of course, there is some latency between your data source and the final data refreshness. So it's about but it's about second level. So actually, which means that start from your data ingestion and at the query data query, the gap is about 1 or 2 seconds, so it's very fast. So I think there is not much cost to ingest your data and copy into the Doris internal format.
Great, thanks. Mark, hopefully that answered your question. If not, feel free to unmute yourself, turn on your mics, and clarify the questions with Rainer. So we've actually gone through all the questions in the chat. Does anyone have any other questions they want to ask Rainer and the VeloDB team? Feel free to unmute yourself and turn on your mics. So Rainer's sharing the QR code again for those folks who want to join the Doris community. I think this is, it's the Slack.
Yeah, we have a very professional team to help you to answer any questions.
Yeah. And sorry, Rainer, speaking of which, if there are folks here from companies or enterprises who could potentially become your clients, VeloDB clients, like how would they get started? Like, would it be like a demo with VeloDB's team, and then, or would you help them identify use cases? How would folks get started with VeloDB in terms of the commercial enterprise version of Apache?
Yeah, this is our website, so you can get started free to test our product, and also you can join the Slack, and the Slack is all for the open source users and the customer the commercial users, so you can connect us through the Slack.
Yeah. And there's been a lot of talks recently, across industries and markets, sort of between deploying solutions on the cloud versus deploying on-prem. With the VeloDB, of course, you have the cloud SaaS version, but Do you also offer support for deploying VeloDB on-prem for your clients?
Yeah, yeah. We had a VeloDB Enterprise version, which is on-prem.
Yeah, perfect. Okay, great. Can Doris be used to Windows? Okay, I guess someone already answered that. So no support for Windows servers yet. Okay. So I'm guessing these are when you install and deploy this. Is it like Linux?
Yeah, we only support Linux system.
Any other questions? No. Shawa, any last thoughts, or you want to help? Maybe if you have any questions, Shawa, do you ask? You know.
Not question to Rainer, but I'd like to, thanks everyone for joining this event, and just want you to know that this is part of, a webinar series. So we would love to hear, feedback from everyone. After this event, we'll send a follow-up message or email, and then we'll share the slides and the recordings with everyone. Feel free to help us spread the word on LinkedIn, social media, and then stay in touch for upcoming events with VeloDB. So we look forward to receiving any, if you would like to hear more about a specific aspect of VeloDB, you want to have a more technical session, feel free to let us know, and we'll try our best to make it happen.
Great, thanks, Shawa. Rainer, last words for you, if you want to close out the session.
Okay, I'm all done. Thank you all.
All right, thanks, Rainer. Thanks, Kobe. Thanks, VeloDB team. Thanks, everyone. Have a
Thanks,
great rest of the
everyone.
night. Yep, have a great rest of the night.
Goodbye.
See you the
Bye-bye.
weekend.